In this video, we're going to cover section 1.01, looking at an introduction to angles. We measure angles using degrees, and we can have both positive or negative angle measures. A positive angle measure is measured counterclockwise. So starting from your initial side, counterclockwise results in a positive angle. A negative angle is measured clockwise. So starting with our initial side, moving clockwise to our terminal side results in a negative angle. Our degree measure, 1 degree represents 1/360th of a rotation. What this means is that there's 360 degrees in a full rotation. We have some special angles. Our first angle illustrates an acute angle. And an acute angle has an angle measure between 0 and 90 degrees exclusive. So our angle theta is between 0 and 90 degrees. Theta is a Greek symbol that we use a lot of times to represent an angle measure, although we can use variables like x, like we've seen in an algebra course. The next angle, illustrated or denoted by this small square in the bottom corner, is a right angle. And a right angle has a measure of exactly 90 degrees. Our next angle is a little bit bigger. This is called an obtuse angle. An obtuse angle has an angle measure between 90 and 180 degrees exclusive. And then our last illustration, a straight line represents what we call a straight angle. And a straight angle has a measure of exactly 180 degrees. Complementary angles are two positive angles whose sum is 90 degrees. Supplementary angles are two positive angles whose sum is 180 degrees. Find the measure of the complement and the supplement of an angle measuring 40 degrees. To find the complement, we're trying to figure out what angle added to 40 gives us 90. So we're going to figure this out by taking our 90 degrees and subtracting 40 to give us 50 degrees. To find the supplement, we're going to do a similar thing, but the supplementary angles sum to 180 degrees. So we're going to take 180 and subtract 40. So the complement of angle 40 is 50 degrees, and the supplement for an angle of 40 degrees is 140 degrees. Find the measure of each angle given in the picture. So in this first figure, we know that we're dealing with a right angle because of that little square in the bottom corner, which means that the total angle from here to here is 90 degrees, making the two angles that are composing that complementary. Which means that our two angles of 6x and 3x must sum to 90 degrees, and we can solve this equation for x and use that to find our two angles. 6x plus 3x is 9x is equal to 90, and if we divide both sides by 9, x is equal to 10. Now, the directions asked us to find the measure of each angle, so be very careful. Make sure you're reading the directions carefully. So our first angle, 6 times 10 is 60 degrees. And our second angle, 3 times 10 is 30 degrees. In our next illustration, we see that those two angles form a straight line, making it a straight angle, meaning they're supplementary. If they're supplementary, that means the two angles sum to 180 degrees. Again, we'll solve this equation for x and then use it to find the values of the two angles from the picture. 4x plus 6x is 10x equals 180. And if we divide both sides by 10, x is equal to 18. From here, we can find that the two angles, 4 times 18 one angle is 72 degrees, and 6 times 18 is 108 degrees. Another method for measuring angles is in degrees, minutes, and seconds. Now, degrees, minutes, seconds is most commonly used for latitude and longitude, or even potentially navigation. Now, our notation for degrees, minutes, seconds is degrees. Minutes has an apostrophe, and seconds has a quotation or two apostrophes. We know that 1 minute is equal to 1 over 60 degrees, or 60 degrees is equal to 1 minute. Excuse me, 60 minutes is equal to 1 degree. And I can find this just by rearranging this, multiplying both sides by 60. 1 second is equal to 1 over 60 minutes. So it's a 60th of a minute. Likewise, we can rearrange this for a little bit easier of a conversion. We know that 60 seconds is equal to 1 minute. Now we can also convert directly from seconds to degrees. 1 second is equal to 1 over 3,600 degrees, or 3,600 seconds is equal to 1 degree. Now, throughout this set of guided notes, I'll be using Desmos most frequently just because it's a free online graphing calculator. There is an opportunity to use like a TI-84 or TI-83 to convert between degrees, minutes, seconds, and degrees. However, since it's not really necessary that you have that tool, I'm going to focus on using these conversions when I'm going back and forth between degrees, minutes, seconds, and degrees. But if you're interested in finding out more about how to use the technology within the TI-84 system, I'm happy to discuss that with you. Or you could YouTube it. Perform each of the following calculations. We want to add two angles, 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. I'm going to stack these vertically so I can start combining like terms. So 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. So I'm going to combine my minutes, combine my degrees. 29 minutes plus 46 minutes is 75 minutes. 51 degrees plus 32 degrees is 83 degrees. Now, 75 minutes, if we think about this, that's more than, I'm going to use the idea of an hour, but more than 1 degree. So we can simplify this. So 75 minutes is 60 minutes plus 15 minutes, and we know that 60 minutes is 1 degree. So that 75 minutes becomes 1 degree, 15 minutes. And I'm going to combine that 1 degree with the 83 degrees. So we get 84 degrees, 15 minutes when we add those. Subtraction, we have 90 degrees. And I'm going to put 0 minutes here just so that we have a like term to combine with. Minus 73 degrees, 12 minutes. Now, thinking about subtraction from back in elementary school, I can't do 0 minus 12 because I can't take away 12 from 0. So what we're going to do is we're going to rewrite this. We're going to take one of the degrees from the 90, leaving us with 89 degrees, and we're going to convert it to 60 minutes. Now I can subtract 73 degrees, 12 minutes by combining like terms. 60 minutes minus 12 minutes is 48 minutes. And 89 degrees minus 73 degrees is 16 degrees. Convert 74 degrees, 8 minutes, 14 seconds to decimal degrees to the nearest thousandth. So converting from degrees, minutes, seconds to degrees, we're going to be using these conversions. "74 degrees is going to remain, but that 8 minutes, 14 seconds, that's what's going to create my decimal for this degree. So the 8 minutes is going to be out of 60 because there's 60 minutes in an hour or 60 minutes in 1 degree. And the 14 seconds is going to be divided by 3,600 because there are 3,600 seconds in 1 degree. And we can use a calculator like Desmos to calculate this, giving us 74.137. So let me show you Desmos real quick. You can find Desmos by going to desmos.com. Again, it's a free online calculator. They do have graphing calculators and scientific calculators. I default to the graphing calculator. We will be using graphing in this class, so it just seems like a good tool to use, even though we're not using it for this particular example. But I wanted to show you how user-friendly Desmos is, and to really try to emphasize just how wonderful of a tool it really can be for us. So thinking about that example we just did, it was 74 plus, we wanted to add 8 over 60. So if I do 8 and just do the slash on my keyboard, if you notice, I automatically got that beautiful vertical fraction like we're used to setting up on our paper. Now, I can't keep typing, so if I press plus, I'm still in that denominator, so you can kind of see where your cursor is. I'm going to scroll just to the right so I get out of that fraction and then continue the rest of my expression. 14 divided by 3,600. And there's our decimal value. And if we round to the thousand, that was that 0.137. Next, we'll look at converting from decimal degrees to degrees, minutes, seconds. So we've got our 34 degrees, that's our whole number. So we've got degrees, minutes, seconds. Again, the degrees is that whole number 34, and that 0.817 is what gives us our minutes and our seconds. So we're going to start with that whole decimal 0.817, and to find our minutes, we're going to multiply by 60. Now that gives us approximately 49.02 minutes. And what we're going to keep here is just the 49. So we're keeping the 34 degrees and the whole number of minutes of 49. Now this remainder of the minutes is what we're going to convert to seconds. So we're going to take that 0.02 and multiply it again by 60 seconds. This was multiplied by 60 minutes. And that gives us 1.2 seconds. Now the direction said to round to the nearest second. We're going to round to the nearest tenth of a second. So we're going to keep that 1.2. But essentially we're going to put all three of those together. So we have 34 degrees, 49 minutes, 1.2 seconds.